Hey there, in this video we're going to talk about all the essential functions that we'll need for Calc 1. So I kind of have a little diagram here showing all the different functions we're going to study. So we have our polynomials, which linear functions are in there, polynomials, rational functions, algebraic functions, and then we have our transcendental functions, which are logarithms, exponentials, trigonometric, and many more. So we'll study all kinds of functions in this class. So let's talk about our linear function. So for a linear function, we know it has the form y equals mx plus b. So we have to find our b and our slope. Another version of the equation of a line is, right, you can use the y minus y1 equals m times x minus x1 when you have 2 points. So here, find the function determined by the line that passes through these 2 points. Now notice that 0, 3 is the y-intercept. So we should be happy about that because that means that we know that b is 3, right, in our y equals mx plus b. So all we really need is the slope. So what is the equation of slope? The slope is the change in y, so y2 minus y1 over the change in x, x2 minus x1. So in our case, it doesn't matter which one you start with. I'm going to start with the first point here. So our slope is going to be 3 minus a negative 1. Since I started with 3 for the y, I have to start with 0 for the x. 0 minus 2. So I have 3 plus 1, which is 4 over negative 2. So the slope is negative 2. And I know that b is 3, so using my y equals mx plus b, or f of x equals mx plus b, now I can write our equation of the line will be, putting this together, y equals the slope minus 2x and then the y-intercept. You could have also used y minus y1 equals mx minus x1 to find the same equation. So that is a linear function. Polynomial functions are functions that look like this. P of x equals a sub n x to the n, and you have all the degrees in decreasing form. So where n is a non-negative integer. So in order to be a polynomial, you have to have either 0, which would mean just a constant function, or it has to be positive, 1, 2, 3, and so on. So the function here, 5x to the 7th minus 2x cubed plus 1/3 x plus pi is a polynomial function. What is the degree of this function? The degree will be the highest exponent. So in this case, x to the 7th is the highest, so the degree is 7. Now pay attention that they're not out of order. So sometimes you may have like the 2x cubed as the leading term and then the 5x to the 7 at the end. Just write them in decreasing order, and the one with the highest exponent, that is the degree of your polynomial. So this has degree 7 and it has how many terms? 1, 2, 3, 4 terms. So this is a polynomial. If it had 3 terms, we call it trinomial, and so on. Our power functions. So a function of the form x to the p, where p is a constant, is called a power function. When p is just a positive integer, then those power functions become really one-term polynomial functions. So notice that essentially this polynomial function is made up of the addition and subtraction of various polynomials. So that's what makes it multiple terms. Now here, x to the p, so this first graph that I've shown you is the cube root of x. So we can really think of this as x to the what power? X to the 1/3, right? So in this case, p is 1/3. So it just says p is a constant. So it doesn't say it's an integer. So it just says it's a constant. So p equals 1/3. So you get a cube root. P will be 1/2. You get the radical function. And then these are polynomial functions because you have a whole number, positive integer. Y equals x squared, and your x cubed. Rational functions. A rational function is a ratio of 2 polynomials. So P and Q, P of x and Q of x are polynomials, and Q of x cannot be 0, right? So we don't want, anytime we're dividing anything, we don't want the denominator to be 0. So that's what that is. So that's really important here. So given this function, this is a rational function, you have a polynomial on the top, right? Positive or non-negative integers. So they have to be integers, positive or 0. And same on the bottom. So this is a polynomial function. So we want to know what's the domain of this function. So we know as soon as you see a denominator, we know the denominator cannot be 0. So you're going to exclude the x values when x squared minus 4 is 0. So when does that happen? X squared minus 4 is 0. Factor that out. That factors into x minus 2x plus 2, which means that x equals 2 or negative 2. So those are the values that make it 0. So we will say the domain is all real numbers except negative 2 and 2. So how do we say that in interval notation? Minus infinity to minus 2 always go from left to right on the number line. So from smallest to largest. Not including minus 2, then minus 2 to 2, and then 2 to infinity. Now again, if you have a hard time going directly from that to the interval notation, draw yourself a number line. What would you shade? So I will put minus 2 and 2. And those are not included, so open circles. But then everything else is okay, because it says all real numbers except minus 2 and 2. So I will shade everything except those two values, and then that translates to our interval notation. Now for trig functions, the one thing to remember about trig functions is that we have to be in radians. So if you try to use a graphing calculator, even though graphing calculators in Calc 1 are not to be used, right? Just because we're learning the basics of all graphs in Calc 1, so I would rather you use a scientific calculator. But if you're graphing, just make sure that your mode is in radians. Otherwise, you're probably going to get an error. So trigonometric functions plot the value of the particular function using radian measure. So that's really important. And so, for example, f of x equals sine x plots the sine of the angle whose radian measure is x. So when I have, for example, if I pick x equals pi over 2 here, right, that's the radian measure, that's my angle. And so what the function is doing is then plotting the value 1. So this is the point pi over 2 comma 1. So the angle in radian measure is pi over 2. The function value is 1. And you can think about that with cosine as well, and tangent. Tangent is the one that has the asymptotes. And then we have our exponential and logarithmic functions. So exponential functions have the form b to the x. So this one, a lot of them have the 1 as the y-intercept. I believe the one that I graphed here is log base 2 of x. But this is the general form, and then this you have your logarithm. The relationship between exponentials and logarithms is that they're inverses of each other. And as we get into logs, I'll remind you of the definition of a log, because logarithms are really exponents. All right, so let's classify the following functions as the types we just studied. So f of x equals 5 to the x, what would you classify that as? This is looks like exponential. B is the constant and x, the exponent is the variable. I should say the base is the constant and the exponent is the variable. So here the base is the constant, the exponent is the variable. So this will be an exponential function. What about this one? This one you can classify in two ways. You can say this is a power function, but because it is also a positive integer, you can say this is a polynomial function. So it will be a one-term polynomial function. D is definitely a polynomial function. And what's the degree of it? Degree 4. And so notice this one is not in descending order. The highest degree is at the end, but we can still determine the degree. What about C? I had skipped that one. What is this? It looks like it might be rational, right? At first glance, you're like, oh, that's rational. It has a numerator and a denominator. But let's go back to what it means to be a rational function. A rational function is p of x over q of x, where p and q are polynomials. And to be a polynomial, you have to be a non-negative exponent. Whereas this, right, the square root of x is x to the 1/2. That is not an integer. So this is not a rational function. We just call this an algebraic function. So algebraic functions are functions that are made up of other functions by doing algebraic operations like adding, subtracting, multiplying, and dividing. So in this case, we have a polynomial in the numerator, but we have a power function on the bottom. So this will be, and we divided them, so this will be an algebraic function. Okay, so in the next, I'm going to record another video and we're going to do these two examples. Find an equation of the quadratic given below, and we're also going to find a formula for a cubic function given some zeros. So that is on the next video.